Hi, this is Mr. Max. So I gave a test to the grade 12 learners who are doing core mathematics, and it was about probability, vectors, and transformation. All right, so the very first question, if I go directly on to the question, says that a normal pack of playing cards consisting obviously of 52 cards, as you can see here, some of them are black, some of them are red. In fact, we have got exactly half in every suit, there's 13, so it's exactly 26 of the cards here are black and 26 are red. So you have got aces here, all right, and then you have got your hearts and your diamonds and your clubs and your spades. This is the spade, and the clubs are the ones on top here. And then you also have cards that are labeled between 2, 3, 4, 5, 6, 7, 8, 9, and 10 with the aces, obviously. Then your jacks, your queens, and your kings. All right, so you have got a jack of spade, a queen of spade, a king of spade, a jack of clubs, a queen of clubs, a king of clubs, a jack of hearts, a queen of hearts, a king of hearts, a jack of diamond, a queen of diamonds, a king of diamonds, for example. Okay, so we're going to ask you a few questions just relating to this, just on probability. Okay, theoretical. Right, so the first question says that when we pick a card at random, we are supposed to find the probability that you get a heart. Now, if you count, you realize that you have got exactly 13 hearts here, okay? The exactly 13. Doesn't mind whether you take the ace or the 2 or the 3 or the jack or the queen, as long as you pick them. So you simplify that fraction, you get 1/4. Okay, so with probability, if you write it, 52, yes, you get the mark, but try to simplify them wherever it's possible. Okay, no need to change these things to percentages and decimals. All right, just proper fractions in their simplest form, it is better. Then a black card, again, as you know, I said this right in the introduction, there are 26 of these black cards out of 52. All right, the probability that something event occurs is between 1 and 0. So the answer here is 0.5 or a half. The probability of picking a 4, now if you look, there are 4 4s that you can find in this particular deck of cards. So it then simplifies to 1/13. A red king, well, there are only 2, is either the heart or the diamonds, or 2 of them out of 52 should give you 1 out of 26 when you simplify them. Now here's the thing, whenever we bring in jack, queen, or, the moment you realize we are listing them and we are asking or, it means you're supposed to add, okay? So we add all the jacks, they will be 4, all the queens, they will be 4, and all the kings, they will be 4 exactly. You simplify and you get 3/13. An ace of spade, right? So your spade is just going to be 1 here, okay? So that is just going to be 1 out of 52. An even numbered card. Now they are not saying the color here, just the even numbered card. All right, so you expect 20 of them. That is a 2, the 4. Let's take the first suit here. All right, the clubs. You have got 1 for the 2, the 4, the 6, the 8, and the 10. So they're about, if you count them nicely, you'll get 4. 1, 2, 3, 4, 5 of them. So 5 times 4 in each suit gives you 20. So it will be 20/52, which simplifies to 5/13. Lastly, they are saying a 7 or a club. Now, so how many 7s do you have there? You have got 4 7s. All right, and then obviously now a club. Now there are 13 of the clubs there. Okay, that's the top one there. But you can't count the 7 again because it's already considered here in the first instance. That's why you see I subtracted it from there. You simplify that fraction, you should get 4/13. Right, the second question here, they are saying in the following, so you have got vector A here, 2, 6, vector B, -3, -1, vector C, -2, 4. So you were supposed to add here, find the sum of vector A and vector B. So you just add the components, the X components together, and then you add the Y components together, right? 2 plus -3 is the same as 2 minus 3, that gives you -1, and 6 plus -1 is the same as 6 minus 1. It gives you 5. Remember, when you have two different signs here, you tend to change it to a minus. Right, here they want you to find the difference between B and C. So vector C minus vector B. So you just go get your vector C, which is -2, 4 here. and your vector b, which is negative 3, 1, and you subtract them. So I wrote them nicely here for you. So you have negative 2 minus negative 3 and 4 minus negative 1. By the way, if you just punch on your calculator negative 2 minus negative 3, it should give you 1. All right, two identical signs between a number gives you a positive. However, you should get this answer without struggling. Then they say 3 times the vector c minus 2 times the vector b. So 3 times vector c minus 2 times vector b. So remember that 3 multiply with each component that you find in vector a. Okay, vector c. All right, so each component vector c, that negative 2, that 4 must be multiplied by the 3. And here the negative 2 multiply each component also. You see, I changed it to a positive because a negative times a negative will give me a positive answer. Okay, right. So once you clean that up, it should definitely arrive at 0, 14. Right, so question 3, you are asked to, if I bring the diagram, write OA as a column vector and also OB, or no, AB rather. So OA is straightforward, is 3 units to the right and 3 units upwards from the origin. A to B, you realize that there is no direction in terms of the X. All right, doesn't go to the left, doesn't go to the right. So that's going to be 0, and then just going down by 2. So it's 0, negative 2. Now they're saying that O to C, as you can see here, is equal to some quantity times what vector OA is. All right, so if I was to write down O to C and you count, it's 9 across and 9 upwards. All right, that is how I write it as a vector because it's from the origin. And I know what OA is. So if I just simply now multiply each one of those components at vector OA by 3, and I take one row, all right, if I take one row there and I multiply 3k equals to 9, I know that the value of k should definitely equal to 3. So now they are saying on the grid here, you're supposed to draw the image of triangle OAB, this line, this triangle here. You should draw it in the line x equals to 4. So I bring my line x equals to 4. So remember, it's going to be each point on OAB will be exactly the same from the mirror line. So the reflection, therefore, has to be a diagram like that. They say draw the image of AB, only the line AB, under a rotation of 90 degrees, anti-clockwise, all right, about point A. So it goes this direction, and that is how that line is supposed to be drawn. Now they are saying complete the triangle OCD. Well, I completed it, so that's what you do. And they are asking you to describe the single transformation fully that maps OCD. You see, OCD is the big one onto the small one, OAB. All right, so you can say it's an enlargement, and the center of enlargement is the origin, because you can see, and the scale factor is the image. Now here's the thing, the image is triangle OAB, the small one, and the object is the bigger one because it says OCD onto OAB. Okay, so if you take that vertical distance there, you get 6 blocks or 6 units, and you take the corresponding vertical distance here for the small one, you get 2 units. When you divide them 2 together, you get 1/3. That is how you find the answer to that particular question. Right, so we have got question 4 here, and then if I bring the diagram, they're saying you're supposed to mark and also at the same time label, okay, the rotation, the center of rotation. So what you do is you probably will take your graph paper or your tracing paper rather, and then you're going to trace triangle A on, and then you're going to find somewhere around this area here. Maybe you start with 1, -1. Maybe you start with 1, -2, 1, -3. Anywhere in this particular vicinity. All right, and then you turn it with your pencil. Obviously you need to trace it on, and then when you see that if this triangle is superimposed on this one, that particular place is going to be your center of rotation. Okay, so in this particular case is the point 1, -2, as you see there. Then they're asking you here to reflect this one, the blue one here. Okay, so let's bring that line in, y equals to -2. So this is our mirror line. So our triangle or our trapezium, our shape is going to be exactly halfway from this mirror line. So something like that. Okay, so that is how you do this particular questions. If you want the questions to the test that I gave, you can check them out on my Google Classroom.